How do mathematicians solve self-referential loops? Imagine a puzzle that keeps talking about itself, like a sentence saying, "This sentence is false." These are called self-referential loops, and they can cause big problems in math and logic. When a statement refers back to itself, it can create paradoxes that seem impossible to resolve. Mathematicians have developed clever ways to handle these tricky loops without getting stuck in endless confusion. They start by making the ideas very precise, so they can control how self-reference works. One important tool they use is called Gödel numbering. This method turns statements into numbers, so a statement can talk about its own number indirectly. This way, they can analyze and understand self-reference without causing contradictions. Gödel work showed that in any powerful enough system, there are true statements that cannot be proven within that system. To do this, mathematicians use a process called diagonalization, which involves creating formulas that say something about their own provability or truth. This process is like writing a statement that says, "I am unprovable," and then studying what happens. In computer science, recursion is a form of self-reference that is very useful. It solves problems by breaking them down into smaller versions of the same problem, with a clear stopping point called a base case. For example, counting ways to tile a big chocolate bar can be done by counting ways to tile smaller bars, then building up. When loops or paradoxes don't settle down, mathematicians sometimes use iterative approximation. They start with a guess and refine it step by step, hoping to get closer to a solution. Sometimes, they use special logical systems that weaken the usual true or false options, allowing them to handle paradoxes better. They also study metadynamics, which looks at how theories evolve to handle self-reference while staying stable. These methods help mathematicians and computer scientists work with self-referential systems safely. For example, programming languages use recursion and reflection to create self-modifying code or compilers that can compile themselves. This shows how what once seemed like a problem can become a powerful tool when understood properly. So, in the end, mathematicians solve self-referential loops by carefully encoding ideas, using logical frameworks that prevent contradictions, and applying iterative or alternative logical methods. This turns a confusing paradox into a useful way to understand and work with the fascinating world of numbers and their patterns.